Bismillahirrahmanirrahim. Assalamualaikum and good day to everybody. Okay, this is the fourth part of our video related to system design, where I'll be covering the last part of the content related to this topic, which is on architectural model. Another. Right. Okay, let's look at architectural design. So just now you have seen different kind of modeling, context, interaction, structural, and also behavior. Okay, talking about architectural design is basically the overall, this a way of organizing and designing the overall structure of the system. Just now we took take a look at class diagram, right? So that's a way of organizing the structure of the classes. But architecture design is actually covering the structure for all of the uh, uh, classes and components in the system. So architecture decision is a critical link between design, what you have done in design, and what you have designed in requirement engineering. So design is that we go for slightly more detail, what are the classes and so on, what is the method inside. Requirement engineering is that we want to capture the non-functional and functional requirement, right? So and architectural design is basically linking them together. So the output of the architectural design is a architecture model. So it's basically an overall view of the system, uh, and to see how that components. So components is made up of many classes inside it. So you can think about as packages in your Java program. Okay, so that's how you can visualize component. Right. If we are using agile development method, so coming up with an architecture is actually done in the early stage of agile. Okay, because if you still remember in agile, everything is being done in a smaller cycle, right? So if you don't have the overall view of the entire system, it's pretty hard to identify which stages or which part of the component that have been developed. Okay, so if we are talking about architectural view, this is how it looks like. So it has many representation, but basically it is represented in terms of boxes. That boxes is actually showing component within that. Or sometimes that component can be thought of another system or subsystem. Okay, so in here it's showing an architecture of a packing robot control system. Okay, so whereby it has this version system, and then there is an object identification, and then it has this arm control. This is the gripper control, the one to grip the box. Okay, and then so it's showing you packaging selection system, and then the pack system, the conveyor, the system to move the boxes from one place to another, right? So basically, if you are thinking about architecture model, so this is how it looks like. So it composed of a component or sub component, and it's basically showing at a very high level how this does this component interact with one another. Right. Abstract architecture can be seen in two perspectives. Okay, architecture in small and architecture in large. Let me take a look at the architecture in large, the one that you have seen just now, the packaging robot system. It's actually it is in a form of architecture in large, where you actually look how the system, how programs, and how the program components actually interact with one another. Okay, this system, this enterprise system are sometimes distributed. Okay, the system is not in one place; it's somewhere else. Okay, and some might be owned by one company, another one owned by other companies, right? So that's how you can visualize that the component is not in one place, but everywhere. Okay, architecture can also be seen in smaller perspective, where it is concerned about individual program like your classes, yeah, um, and how from this a collection of individual programs you can compose it into uh, different components. Why do we have this architectural diagram? Okay, because as you can see just now, it is um, giving you an overall view of the main system, main component that will interact with one another. So it is easier to be used to communicate with the stakeholder, those who are involved. Okay, because we are giving them an overall view, so they know what are the main system might be involved, how do they react. All right, and then it is also for the purpose of system analysis. Okay, because remember I mentioned just now, this architectural diagram is actually used to link the design and also the requirement engineering, right? Remember when we are covering on requirement engineering, we are identifying not only the requirement but the non-functional requirement. That non-functional requirement can actually be addressed through this architecture diagram. How it is done, so I think covering that in the following slide. And then if we have this architecture, especially for large scale, it can actually reuse it. For example, um, nowadays, there are many um, product related to smart TV, right? But technology keep on changing. Maybe one year they come out with a new one with additional function or features, and then with a different size screen, right? Different size screen with different technology, and so on, right? So they normally have this architecture that they keep on reusing it, but with adding of new component and removing the old component. Okay, so the architecture is there, they modified. So this kind of architecture is being called product line architecture. The same goes with a mobile phone right now. Let's say for Samsung, they have so many models, right? So it actually they have their own architecture that they keep on changing it uh, as they go along upgrading the technology. Right, it can be in terms of representation, it can be box. Actually, there is different ways on how to draw it. Okay, so there are many. This representation has been criticized because it lacks semantic. Okay, it does not. Maybe different people will interpret it differently. In order to draw architectural model, also there are many styles. So sometimes it is being drawn in a very abstract way, but this kind of information, even though it's abstract, it still is a good way of using it when communicating with the stakeholders, okay, with the manager, with the user from different department, and it's good for planning because when you have the overall architecture, you know how many components, right? So you can it give the project manager a better system, a better overview of the system, so that you can predict, okay, this one component can be done how long, okay, so which one has to be done before the other components, because by looking at the arrow, okay. Right. With architecture model also, I mentioned that it can be used for discussion with the stakeholder. It is actually a way of provide us some information about what components involved, okay, how they are interacting with. Coming to this, architectural decision, when you are drawing or creating the architectural diagram, it's actually um, help you to address some common decision related to design processes, what non-functional functional requirement characteristics that the system is trying to achieve. Right, I've mentioned just now, um, the functional requirement normally is being addressed in class diagram, in context diagram, but the non-functional requirement is actually being addressed in this architectural decision. Okay, so among the questions that the software architect uh, will be looking into when they are doing this architecture design is that they will start looking, is there any generic application architecture out there in, in the form of maybe there is a template that they can reuse. Okay? Because nowadays there are actually many research done in this area where they provide template. Okay? For example, if you want to achieve performance of the system, which is a non-functional requirement of that system, follow this kind of template. Okay? If you want to have a secure system, they have different template. So it's easier for the system architect to design the overall system. Right, and then you should be thinking also, is this system will be distributed or not? Okay, where will it be distributed? Will it be owned by one company or how? Okay, is there any pattern in architectural itself as it goes along in being used by the software architects? They have come up with certain patterns and styles that you can follow. Okay, maybe their architecture in a layer form, right? Pipe and filter. So each of these pattern is actually trying to achieve a certain non-functional requirement. Okay, and then how will the structural components can it be decomposed? Right? So which architectural organization is best to deliver certain specific non-functional requirement? Okay, how to document it? Okay, so when the system architect is coming up with an architecture diagram, so this is among the main questions that must be thought of. Okay, by them. Right. So architectural, when you have diagram, architectural diagram, it is actually meant for reuse, especially if you have different version of the system later on. Okay, architecture can be reused with modification in certain components. Okay, just now earlier on I've mentioned that through architecture diagram can be used to link the requirement engineering and also the design, especially in representing the non-functional requirement. So actually this area of study has been there for quite some time. So there have been many research done in identifying certain common templates that the software architect can use whenever they wish to, for example, achieve performance non-functional requirement for their system, where the idea is to have very large component where the critical components or operations is actually put in one place uh, in order to reduce communication. If there are many components, to achieve performance, we don't want too many interactions happening between components. So we want critical operation is put in one place so that it can be executed in a very fast manner. Right, if you want to achieve security as a non-functional requirement, so it is recommended that layered architecture is being used. So all the components are actually in a layer form. So one component talk to the component above, and the above one talk to the component underneath. All right, so whereby the critical asset is actually put in an inner layer just to make the access to the critical assets harder. And to achieve safety, so all the safety critical features is put in one place in a small number of subsystems. Okay, so that's another way of achieving safety, whereby for availability, so you want to have the system available all the time, like the online banking or online shopping. So what you need to do is to design a software architecture with many redundant components. Okay, one component always have another backups, and also it must have mechanism for fault tolerance. So it should have mechanism to handle errors. Okay, if some error happen, if there are some fault, how they can manage it properly rather than shutting down the system straight away. And then if you want to achieve maintainability, okay, you want your system to be easily to maintain, to adapt changes. Okay, you need to design the component in the fine grain, meaning that it's smaller component, so that if there are some changes, only certain you need to only change certain component, and you won't disturb the other components as a whole, right? So that the changes can be done in a faster manner. Hopefully, this gives you some idea on how all diagrams use in design and what you have identified during requirement engineering, in identifying the functional and non-functional requirement can be linked together actually through the architectural diagram. Thank you.